Day 37, number 3. How many milliliters, there's your question right off the bat, of an 8 molar solution of nitric acid are required to prepare 300 milliliters of 8.45 molar solution? Well, what type of reaction is going on here? The answer is there's not a reaction going on here. This would be a dilution. And so we have M1V1 equals M2V2. M1 equals V1 equals M2 equals V2 equals. All right. So let's see here. M1, 8 molar. Don't know V1. M2, 0.45 molar. And V2 is 300 milliliters. I'm looking for V1. So V1, I don't know why I did the dot there. V1 is equal to M2 V2 all over M1. So V1 is equal to, looks like it's going to be M2. M2 is 0.45 molar. V1 is 300 milliliters. And M1 is 8.00 molar. So it looks like V1, if we plug this into our calculator, we should get 17 milliliters, because V1 can only have 2 sig figs because of the 0.45. So there's number 3. Moving on to number 4. Concentrated hydrochloric acid is 12 molar. How many grams of that hydrochloric acid are there in 2 liters? So we have an amount here of 2 liters. U-N-T, spelling. We have an amount of 2 liters and a ratio of 12 moles per liter. So let's start with our amount. 2 liters of HCl. We know that for every 1 liter of HCl, there happens to be 12 moles of HCl. And we know 1 mole of HCl has a mass, the molar mass, 1.01 for hydrogen, 35.45 for chlorine. So that's 36.46 grams of HCl. And that's all we're looking for. And if we do that math, I get 875 grams. But we only have 1 sig fig, so that's 900 grams of HCl. Wonderful. So that's it. Number 5. The density of an aqueous solution of nitric acid, holy moly, is 1.43 grams per milliliter. It's 26.5% nitric acid by mass. How many milliliters of the solution would be needed to supply 107.10 grams of nitric acid? Well, let's see here. I think it's a good idea, personally, for us to write down these units. So the problem gives me 26.50% and 1.430 grams per milliliter. Let's complete these units. The mass percent, so it's 26.5% nitric acid by mass. So it's nitric acid by mass. So out of 100%, or about 100 grams of my solution, 26.5 grams would be nitric acid. Also, my density is 1.430 grams per milliliter. It's grams of what? Grams of the aqueous solution per 1 milliliter of my aqueous solution. So now that I have these units written out, it makes it a lot easier to know what unit to put where. So if we get ready to convert, because all we're going to do is convert here, I start with my amount of 107.10 grams of HNO3. Well, what has to go on the bottom? It has to be grams of nitric acid, right? Grams of nitric acid come down. That's my unit, and grams of solution will go on top. So 26.50 grams of HNO3 on the bottom, 100 grams of solution on top. Then we have grams of solution have to go on the bottom. And I look, I have 1.430 grams of solution. From the density is 1 milliliter of solution. And now I'm in how many milliliters of solution? And I actually have 4 sig figs, so at 286.2, no, that had a dyslexic moment for a second. Let's try that one more time. 282.6 milliliters of solution. There we go. And there's 5. And we'll do number 6. Number 6, question right off the bat. What volume of a 0.521 molar barium hydroxide solution, basically, is required to neutralize or react with, right? So this is neutralize, this is react with. And it's like completely. So there's not more than just the right amount. So the exact amount of, in this case, base and the exact amount of phosphoric acid. All right, 1420 milliliters or 0.141 molar phosphoric acid. All right, so let's write the balanced chemical equation. We got barium hydroxide, phosphoric acid, and the salt will be barium phosphate. Well, barium, now if we need to, guys, barium's 2 plus, 3 minus. Feel free to do that. So I need a Ba3, PO4, 2. Now that's going to be a solid. It doesn't matter for this problem, but it's going to be a solid. And water is, of course, a liquid. Balance. 3 barium on the right, 3 on the left. 2 phosphate, 2 phosphate. And then I have 6 hydroxides and 6 H pluses, 6 waters. All right, so we have 0.0521 molar barium hydroxide. How many milliliters is my question? And we have 0.141 molar and 14.20 milliliters of phosphoric acid. All right, so we know that we have to start with phosphoric acid. Why? Because we have all the information of phosphoric acid. We do not have all the information of barium hydroxide. So my amount of 14.20 milliliters of H3PO4. We know that for every 1,000 milliliters of H3PO4, we have 0.141 moles of H3PO4. And moles of H3PO4, phosphoric acid on the bottom, moles of barium hydroxide on top. And that mole ratio would be a 2 for phosphoric acid, 3 for barium hydroxide. Now, we know we have for 0.0521 moles of barium hydroxide per 1,000 milliliters of barium hydroxide. So what do we have here? We have an amount, molarity, mole ratio, and molarity. Just to recap that. And if we do this math, we should get 57.6 milliliters of BaOH2 of our 0.0521 mole.